Hello and welcome to this short tutorial on how to configure KellyDown for remote monitoring with survey corrections. KellyDown 4.00.02.01 introduced a new process whereby survey data is automatically corrected by a third-party service provider for magnetic interference from the BHA and fluctuations in the Earth's magnetic field. The KellyDown Survey Editor and the KellyDown Slidesheet Editor may both be configured to automatically monitor for corrected survey data as it is processed by the third-party service provider. Additionally, KellyDown in remote operation centers may be configured to automatically update survey, slidesheet, and drilling records as they are processed at the rig site. Several remote instances of KellyDown may be monitored simultaneously on a single remote computer and tested for proximity and other criteria, which, if breached, will trigger audible alarms and/or broadcast SMS text messages and email messages to selected company or customer personnel. This video explains how to set up KellyDown at the rig site and at the ROC to perform these functions. KellyDown first needs to be set up to transmit email and text messages. This may be configured at the rig site or in the ROC, and different personnel may be selected at either location. For example, the rig site instance of KellyDown may be configured to alert the directional driller if the well diverges from the associated well plan by a certain distance. The ROC instance of KellyDown may be configured to alert ROC personnel, company, or customer representatives if the well comes too close to an adjacent well, thereby avoiding potential problems before they become an issue. First, we need to provide KellyDown with access to an outgoing mail server. Open Administration System Settings, and if Microsoft Outlook is running on the computer, just check the box named Use Default Outlook Account. If Microsoft Outlook isn't installed on your computer, configure the outgoing email server as you would for a mobile phone. Once you have entered the necessary information, click on the Test Settings button to check everything is working correctly. Next, add the contact information for any personnel that you wish to receive alerts from KellyDown. Click on the Add New Person button and enter the necessary information. At the very least, you need to enter their name and email address, and if you wish to send them SMS text messages, enter their mobile number and select their mobile provider from the list. Click on the OK button to save the information to the database. Click on the OK button to close the system settings. If you also wish to include customer representatives in the list of people who will receive alerts, enter their contact information under Company Properties. Click on the Customer button on the toolbar, make sure the current customer is selected, and click on Edit Customer. Then click on the Add New Contact button. Click on OK to save the information and then Close to close the customers list. Finally, before you start the actual job, set the alert parameters under the Tools Options menu. Click on the Proximity options and set the maximum allowable distance from the well plan before an alert is issued. The suggested value is 10 meters or 25 feet. Set the closest well highlight alarm distance ratio, say 10 meters per 1,000. This is the closest distance you wish to come to an adjacent well based on the measured depth before the alarm is sounded. For example, if the current measured depth is 2,000 meters, the alarm will sound and alerts will be issued if the current well comes to within 20 meters of an adjacent well. It's always a good idea to define a scan radius for the closest well scan in order to speed up the calculations. Otherwise, KellyDown may take an excessive amount of time to scan all the wells in a large project. It is not necessary to scan wells that are more than, say, 1,000 meters away from the current well, because there is no chance that the offset well would ever become a collision risk. A distance of 1,000 meters means that no part of the offset well is closer than 1,000 meters to the current survey. If you are drilling a sidetrack and you don't wish to be alerted if you are close to the sidetracked hole, check the box that reads Exclude Parents and Children of Reference Profile. If the parents of the current profile are laterals, then obviously you would want to be alerted when the current well is too close to one of its laterals. Click OK to save the proximity options. For this tutorial, we're going to assume that we've just completed the drilling of run number 3. So open the slide sheet for run number 3 under AA16 in our example database. So now we want to create a new slide sheet that's tied onto this slide sheet. Go to the Tools menu, click on Create New Slide Sheet, and a message pops up to prompt you for confirmation that you want to tie another slide sheet onto the current one. Click Yes. KellyDown closes the current slide sheet, creates a new one, increments the run number from run number 3 to run number 4, and copies a lot of the associated data from the previous slide sheet. For example, the drill string is copied from the previous slide sheet. So if all you've done is change the bit for this new run, you can just change the serial number. The bit distance will also have been carried over from the previous run, so we're going to change the distance from the bit to the sensor on this run. Click on the Edit Bit Distance, and we're going to change this to 15.81 meters. In order for KellyDown to send out alerts, it needs to calculate the parameters that trigger the alerts. So we need to make sure the columns that enable these calculations are selected in our current slide sheet. So right-click on any of the headers and click on Edit Columns. So first we want alerts to be sent out if the current well diverges from its well plan by a certain amount. So we need to add one or more of the columns that reference the well plan. So we're going to choose distance to well plan, high side distance to well plan, and the proposed inclination and azimuth, and add those columns to our slide sheet. We also want to send out alerts when this well comes too close to an adjacent well. So we're going to add the closest well name, the closest well distance, and the closest well clearance factor. And these columns are added to the end of the set of columns already in our slide sheet, and we just want to move our comment down to the end. Click on the comment, hold the Control key down, and click on the Move Down button to move that column to the end. Then click on OK. The last thing we need to do is select the names of the people who we wish to receive alerts when the alert criteria is triggered. So click on the Edit Job button on the toolbar and go to the Alerts tab. Select the names of the people who you wish to receive alerts. Frank Nugent works for True North Directional Services, and we want him to receive an email message and a text message. Harry Wharton also works for True North Directional Services, and we want him to receive an email message. Notice that when we check the email box, the status cell turns red, and that's because we haven't entered an email address for Harry Wharton. So click on the Edit button and enter his email address. Click the OK button, and you'll notice that the status light turns green. And finally, we want to add Herbert Vernon Smith, who works for our customer, and we want him to receive an email message. Click on the OK button to save the alert personnel to the database. If this job is to be monitored at the ROC, we also need to send the ROC a snapshot of the current status of the well and drilling. To do this, we need to export the current status to a KDEX file and place it in our OneDrive folder. So close the slide sheet, make sure the current run is selected, and then click File, Export. And we've created a folder on our OneDrive named KellyDown Watch Files, and this folder is shared by the personnel at the ROC. So we're going to save the snapshot of the current status of our project, and the project is Northern Lights, AA pad, The well is AA16 and the current run is run number 4. So click on the Save button to save the information to the OneDrive folder. So the personnel in the ROC will be informed that the new run is ready to start, and they will import that run into their database in the ROC. Let's open the slide sheet again, and now we can carry on drilling. So as the well is drilled, the directional driller will enter the survey measure depths, inclination and azimuth into the slide sheet, but at the same time the raw survey data will also be sent to the third-party survey analysis company, who will process the data and then write the corrected survey data to the OneDrive folder. So we need to tell KellyDown which file the corrected survey data is written to. So go to the Tools menu and click on Configure as Client to receive survey data. Click on the Select Data file, and the corrected survey data will be written to a text file. And in this case, it's going to be written to this file here, AAPAD AA16 run number 4 watch file. Click on Open, and then we click on Activate. If the survey data file already contains information, KellyDown checks that the information in the file matches the information in KellyDown. And in this case, the survey name in KellyDown is run number 4, and the survey name in the watch file is run number 04. And because this is okay, we can click on Yes to continue. We also need to configure KellyDown to send the updated slide sheet data to the ROC. Once again, click on the Tools button, and this time click on Configure as Server. And this time we want to write the data to a KDSST file. Click on the Select Data file, and we're going to write the slide sheet to a file having the same name but with a different extension, which is KDSST. Select the file. If the file already exists, click on Yes. And then click on Activate. So now every time the data is updated in our slide sheet at the rig site, the slide sheet data will be written to a KDSST file, and the information will automatically be updated on the slide sheet at the ROC. As drilling progresses, the directional driller continues to enter activities into the slide sheet. When a survey is recorded, the directional driller enters the measure depth, inclination and azimuth. At the same time, these three values are sent to the third-party survey analysis company that processes the data and calculates the corrected inclination and azimuth using multi-station analysis and correction. For the benefit of this example, we're going to show the values that the directional driller entered into the slide sheet as accurate to 1 decimal point. So we have 90.3 and 64.1. When the corrected survey data returns from the survey analysis company and is written to the watch file, these values will be updated with values that are corrected to 2 decimal places. So right now, the directional driller has entered a survey at a depth of 1205, the inclination is 90.3 and the azimuth is 64.1. Whenever he tabs off the survey azimuth, the slide sheet information is copied to the KDSST file and will automatically be updated at the ROC. As drilling progresses, the directional driller enters more activities, which could include new survey data. Whenever corrected survey data is received from the survey analysis company, it will be updated in the slide sheet. So now the directional driller has entered a survey at 1,224 meters, and at the same time new survey data has been processed by the survey analysis company. As soon as it arrives, an alarm is sounded and a message appears on the status bar at the bottom of the KellyDown screen informing the directional driller that corrected surveys are available in the survey buffer. If you look at the survey inclination and azimuth for 1221, you'll see that as soon as the directional driller tabs off the field, those values are updated. And so drilling progresses. with the directional driller entering activities and survey data into the slide sheet, and as soon as corrected survey data arrives from the survey analysis company, the data is updated in the slide sheet. Whenever the directional driller enters new data into the slide sheet, the KDSST file in the OneDrive folder is updated, and then the ROC is updated with the new drilling activities and the new corrected survey data as they arrive. Both the directional driller and the personnel at the rig site can independently monitor the survey data for anti-collision, project ahead, and view the progress in the KellyDown visualizer. And whenever any of the alert criteria is triggered, either email messages or text messages will be sent to the personnel listed under the alerts box. Thank you for watching this tutorial. For more information, please visit www.kellydown.ca.